Did you know that black holes, often described as dense and scary, have an intriguing secret? While they do have an incredible ability to attract and swallow everything in their path due to their intense gravity, there's more to the story. Their gravity is so powerful that it can bend light and warp time. But what if I told you that we might have been mistaken about these cosmic phenomena? For starters, they're not actually vacuum cleaners at all. 1. Black holes don't suck everything in. Black holes are often portrayed as cosmic vacuum cleaners, voraciously consuming everything in their path. However, the reality is more intricate and fascinating. These enigmatic entities don't immediately gobble up objects that come near them. They have a designated boundary known as the event horizon. Imagine the event horizon as an invisible line encircling a black hole. Beyond this point, the black hole's gravity is so formidable that not even light, the fastest thing in the universe, can escape. Theoretically, even if you could travel at the speed of light, you'd still be inexorably drawn into the black hole, an idea consistent with Albert Einstein's theory of general relativity. Once you cross this elusive threshold, there is no turning back. The powerful gravitational pull would seize you, and you'd be drawn into the black hole, vanishing from the observable universe. However, there's a silver lining to this cosmic conundrum. As long as you remain on the side of the event horizon opposite the black hole, you are perfectly safe from its grasp. It's a bit like staying on the shore of a treacherous sea, observing its tumultuous waters without being pulled into its depths. Now, if you're having a tough day or contemplating a voyage into the depths of a black hole, there are some extraordinary phenomena that occur once you cross the event horizon, which are worth exploring further. 2. A black hole won't crush you. If you were to get pulled into a black hole, it might not be as violent as you'd expect. Even though a black hole has incredibly strong gravity, it wouldn't instantly squash you like a soda can. Instead, something called spaghettification would happen. Picture this: if you were approaching a black hole feet first, your legs would become long and skinny before your head started to change shape. Once you crossed the event horizon, the point of no return, the stretching you'd experience would be extreme and very painful. The black hole wouldn't crush you, it would tear your molecules apart. This whole spaghettification process would only take a few seconds, maybe a few minutes at most. So remember when I said it wouldn't be violent? Scratch that. This would really hurt. But the silver lining is that you could potentially come back, just not in the same shape as you were before entering the black hole. 3. Things can come out of a black hole. You might have heard that nothing ever escapes a black hole, but that's not entirely true, thanks to something called Hawking radiation. Black holes have a fascinating quantum phenomenon happening at their outer edge called the event horizon. Right there, particles are constantly appearing. Some of them fall back into the black hole, but others manage to break free from the black hole's powerful gravity in the form of radiation, known as Hawking radiation. Over a very long time, so many particles escape the event horizon that the black hole eventually vanishes completely, as if it never existed. However, this process takes an incredibly long time, and you can't put yourself back together from these emitted particles, so I wouldn't advise jumping into a black hole, especially not a supermassive black hole in the center of our galaxy. But there is a positive side. Theoretically, you could collect this radiation to power things on Earth, though we're far from having the technology to do that. We already have alternative methods for producing clean, renewable energy like nuclear fission. Nuclear energy is environmentally friendly since it doesn't produce harmful byproducts like fossil fuels. It also requires less land compared to solar or wind farms to generate a large amount of carbon-free energy. Plus, it's efficient when it comes to waste. So it's a win-win-win. As we work towards a cleaner future, nuclear energy can significantly help us achieve the goal of having 100% clean electricity by 2035 and a net zero emissions economy by 2050. That's a future worth looking forward to, right? At least it's much better than diving into a black hole. 4. Not all black holes are gigantic. You know, there are different kinds of black holes. The most common ones are called stellar black holes. They're what's left after really big stars, at least 20 times bigger than our sun, burn out. Because they're super compact, the boundary around them, called the event horizon, can be several kilometers wide. Then there are supermassive black holes, and they are just massive beyond imagination. The biggest one scientists have seen is right in the middle of the Phoenix galaxy, and it's as heavy as 100 billion suns. Yes, billion with a B. It's not just supermassive, It's a stupendously large black hole, or LAB, you could say. Until recently, scientists thought TON 618 was the largest supermassive black hole, with 66 billion solar masses. But there's still so much of the universe we haven't explored, so who knows, there might be even bigger ones out there. Now, scientists are still trying to figure out how these cosmic monsters came to be. They're also not sure what happens when two of them collide, but it probably wouldn't be a good sight for anything stuck in the middle. But at least we can keep watching them to learn more. 5. Black holes aren't invisible. Black holes are truly cosmic powerhouses with a gravitational force so strong that even light cannot escape their clutches. However, don't be fooled into thinking of them as stealthy, invisible entities in the universe. In fact, they can be rather conspicuous, just not in the way you might initially imagine. Their remarkable gravitational pull profoundly influences the motion of nearby stars. This effect is like a cosmic fingerprint that astronomers can use to identify the presence of a black hole. By observing the altered paths of stars, scientists can infer the location of these celestial giants. Additionally, when a sizable object, such as a star or gas cloud, approaches a black hole and crosses its point of no return, it experiences extreme gravitational forces. This gravitational interaction generates intense heat, leading to the emission of X-rays that can be detected by powerful telescopes. It's almost like a cosmic light show that signals the presence of a black hole. However, amidst all the fascination surrounding black holes, the most tantalizing question remains unanswered. What exists on the other side of a black hole's event horizon? This remains a profound and mysterious enigma in the realm of astrophysics, waiting to be unraveled. 6. Black hole could be gateways to other realities. Some folks think that black holes might work like gateways to other universes. They could be linked to different places and times in space through something called an Einstein-Rosen bridge, which is a kind of wormhole. These bridges are pretty shaky though, and scientists haven't found proof of them yet. But that doesn't mean it's impossible. Imagine if we could use black holes like cosmic subways. Where could they take us? Maybe to a different reality or time, but there's a big issue here. These Einstein-Rosen bridges are super unstable. They could collapse anytime, trapping you inside the black hole before you get to your mysterious destination. And even if you got through it before it fell apart, you probably wouldn't survive. The intense gravity and radiation would likely get you long before you popped out on the other side. Perhaps someday we'll figure out how to travel through black holes, but for now, it's safer to stick to exploring our own solar system. Maybe you'd like to visit Titan, one of Saturn's most beautiful moons.